All right, so let's start. I guess you are hearing me that side. You can hear me, you just respond so that we can start. Can you hear me from that side? No response. All right, so let's just continue. I will just share the link of the recording for start. I will share my screen. So now I am sharing the screen. Sharing the screen. Just be patient a bit. I'm sharing the screen that we can start. Right. We'll continue from what we were doing there on partial fractions, integration by partial fractions, then we'll go to integration by trigonometric substitution. So let's just, today we just have a recap again on partial fractions, because these ones, they normally come and they are easy, which you can scoop all the marks. So let's start the integration, the partial fractions before the parts. So that is my plan today session for partial fractions. Then you give me the feedback about everything, how it goes. So let's see how it's gonna work today. Right. So integration by partial fractions. Integration by partial fractions. So we are making use of partial fractions to integrate partial fractions. Right. We just put our heading for today so that we know what is it that we are working on today. So let's have an example for a exam type question that normally come, for that when you're revising, you can recap. So let's put one of Makoshi's examples, which he normally loves, which he brings in most exams. Let's say the integral. I'm taking it from one of the notes study guides from Makoshi. Integral of x squared 2x minus 1 over 2x cubed plus 3x squared minus 2x dx, always with respect to x. So with the previous slide, which I was explaining the other day, he said if you have seen that the degree of the numerator, like here, the polynomial degree is of degree 2, and then the denominator, the polynomial, is of degree 3 because of the 2x cubed. So if you want to integrate this by partial fractions, so first we have to split it into the numerator and the denominator into fractions. So what is it that we are going to do there? We want to change the numerator and the denominator into fractions. So in this case, which means we are going to factorize. So in other words, we are going to say x squared plus 2x minus 1 is the same as what? Then you factor out a common factor on the denominator. So there we can see that x is common. So I factor out x. Then I say bracket. Okay. So I have not started solving the partial fractions. I'm just giving an expression which is going to help me. And normally that integral, we can call it I. Another way, I is equals to that. So that whenever you want to solve it, you don't have to rewrite it. You just say I will be equals to what? So for this one, we are saying if we factor out the denominator x, it's going to be 2x squared. 2x squared. So the 2x squared plus 3x minus 2. So I have factored out. Now, I want to know what is this equals to. In other words, we can still see that on the denominator, there's a quadratic expression. So that denominator, you can split it again into factors. So which means if I want to factorize that, how do I do the combination, which is 2x minus 1, and then x plus 2. So that is the combination that will give me 2x squared plus 3x minus 2. For example, 2x and then multiplied by x, then minus 2, obviously it's minus 1, and exactly a positive 2. So this will give me a combination of those brackets which I'm looking for to factorize this expression. That is what I want to factorize. So in other words, let's see how we can factorize that. So by partial fractions, the idea is to make the expression be split into fractions. So that is what we are doing here. The reason why we are factorizing, we want to split that integral, the numerator and the denominator, into fractions. So instead of writing that expression, which means it can also be written as x squared plus 2x minus 1, everything over what? Everything over x bracket 2x minus 1. 2x minus 1 bracket x plus 2. So this is how we'll be doing bracket x plus 2. Then from there, we have factored out. Now it's time for us now to use the fractions, the rule of fractions. What do partial fractions say? So partial fractions, they tell us if we are having this situation whereby we have factored out, we can split it into, we can split that numerator and denominator into partial fractions. For example, x squared. For example, mean x squared, that's x squared plus 2x plus 2x, x squared plus 2x minus 1 over that denominator which we have factored out, which means it's x bracket 2x minus 1 as a factor, bracket x plus 2 as a factor. You want to split this into fractions. So this can be written as, we don't know the constant a over the first expression. So the first expression will be x. Now we are splitting it into partial fractions. So this is the integration by partial fraction, which we are trying to do. And plus b over what? The second term, which is 2x minus 1. So then we write 2x minus 1. Plus, we are adding a constant c over x plus 2. X plus. So that is what we are basically doing here on this expression. So now this is what we have done. We are given this integral, which we are having here. Now, we have split it into partial fractions by factorizing the denominator. Now we know what it is in terms of partial fractions. So what is left now is for us to find the what? The constants, A, B, and C. So in order for us to find the constants A, B, and C, we come and say that this denominator, which is x, the denominator x, so it goes into this expression how many times? So which means it goes into that expression 2x minus 1x plus 2. And also we'll be talking of this denominator. This denominator, 2x minus 1. 2x minus 1 goes into this expression how many times? Which means this will cancel. It goes x by that. So that's what we'll be doing. And then we say also this expression goes into this expression and you cancel that. So it goes there. That is the remaining. So that's what we are going to be doing. So now we want to equate the constants. Okay. So we are going to say our numerator is x squared plus 2x minus 1. That is our numerator. Is equals to what? So x goes into this expression. Into this expression, how many times? So you indicate it goes there. A is there, which means A bracket 2x All right. I'm back. Let me continue from the where I stopped. It's just the network that kicked me out. So let's continue with that process when we're equating the constants. So I will share my screen and the recording will be available, and then I will share with you as well. So I will share with you as well. The recording will be made available, and then I'll share. Let me share my screen so that we can continue. Share my screen, then we can continue. Network just kicking me out. All right, so it's set up. Let's continue. So now we have to solve for A, B, and C. So we are solving for A, B, and C. A, B, and C, then it's integration by partial fractions. We want to solve for A, B, and C, the constants. That's where we are now. We want to solve for A. Right. All right, so from there, we are now trying to solve for A, B, and C, the constants that we have found here. Now we want to solve for A, B, and C. X squared plus 2x minus 1 is equals to A bracket 2x minus 1 bracket x plus 2 plus bx bracket x plus 2 plus cx bracket x plus 2. So we want to solve for constants A, B, and C. So from here, we are going to let, if x is 0, which means we are going to eliminate things here. So we are going to use elimination. Okay, so it's elimination method which we are solving. So we are going to use elimination method. So by elimination, what do we mean? We are going to let x equals to 0, the first one. And then we are also going to let we eliminate x equals to 0 to eliminate, to take out b will vanish, c will vanish if x is equals to 0. Then we can solve for a. So we eliminate x is equals to 0 to solve for a. Okay, so that is the idea for eliminating x equals to 0. You're able to solve for a. Then you also let x equals to 2, negative 2. If x equals to negative 2, we'll eliminate this. X equals to negative 2, then I can eliminate b. If x is equals to negative 2, b vanishes. And also, if x is equals to negative 2, this will become 0. Then 0, and then everything vanishes. If x is equals to negative 2, then we'll solve for c. All right, so let's continue. I was just kicked out of network, but I'm continuing from where I left. Let me share my screen, then I continue from there. Let me share the screen. And also, if you are having some questions which you don't understand, which you want to be worked out via WhatsApp, PDF, you can also send the problem, and then you send the particular problem, then you say, please assist me with the working for this one. I can also assist, so that you only don't rely on Microsoft Teams. So sometimes you find out it's not, the network is poor or what, then I can be able to assist as well via WhatsApp. We'll be also able to assist you also via WhatsApp. All right, so let me share the screen. We go back to where we were solving the constants, A, B, and C. So we want to solve the constants, now A, B, and C. So for A, B, and C, we are going to use what we have done. So we let x equals to 0, solve for A, x equals to -2, solve for C. So that is the strategy that we are going to use. Let me just open, and if I was kicked out from the network, but it will be fine very soon. Fine. All right. So whenever you're having a problem with the question, you can also screenshot 1 question, 2 questions, so that each and every day I can put the working for that particular question if you have any problems. Where you need clarity or explanation via videos, I will use Microsoft. Send the link to you. All right. So we're here to say that this they vanish on what conditions? I said they vanish because of x and -2. That's what I was explaining. Now we want to know if we let x equals to 0, what is the value? If x equals to 0, we are going to be left with bx will vanish, cx will vanish. Only this term is the one that is going to remain. Only that term is the one that is going to remain. This one is the term that is going to remain. This term, if x is equals to 0. So which means that if you want to solve for a constant a, if you want to solve for a constant a, then we are going to say that now we want to solve for the constant a. So we are going to say that x squared plus 2x minus 1. So some of the steps you must write them down, so that when I'm this step, I find that I'm not opening the full screen, so you should also copy the step. So x plus 2x minus 1 will be equals to, now B and C have vanished. They are zeros. So we only left with what? A bracket 2x minus 1 bracket x plus 2. This is what we are left when x is what? When x is 0. So which means bx and cx, they are going to vanish because they are being multiplied by 0. So any number times 0 is 0. So that's why we are left with this. So from here, now you expand the bracket. You expand the bracket so that we equate coefficients. So it will be a, now bracket 2x squared plus 4x, 2x squared plus 4x. Where is the 4x coming from? Which means 2x plus 2x, the last 2, and then minus 2. So we are saying this times that 2x squared. And then the first and the last term, which means it's 4x. 4x minus x. So it's 4x minus x, and then minus 2, the bracket like. So that's what we are having for A. Then we equate the coefficients. So if we take the coefficients in the x squared, we are equating the x squared only. We are equating the x squared only. So what are we going to say? So if we expand it there, we are going to find out that A brackets 2x plus 3x minus 2 is equals to that. So it's a square. It's equals to that. So which means we are going to equate the coefficients in the x squared. In other words, we are saying A multiplied by 2x squared plus A multiplied by 3x minus A multiplied by 2. So we are multiplying by 2. The dot is just multiplying by 2. So which means we are going to equate this x squared with this x squared. Then we can solve for what? For x. That's what we are doing there. So once we have equated those two, we are equating to say x squared is equals to 2a x squared. This one. What is the value of a? We are going to divide both sides by what? 2x squared. We divide both sides by what? 2x squared. So they cancel. The x squared, they cancel. The 2 and the 2, they so A is up. Right. So let's continue. I guess you are hearing me. The network is not that good, but we are trying to manage. Let's just push and we manage. Everything will go well. So let's share the screen so that you can see. And for the comments, everything for improvements, you can put it in the comment section so that I know what is it that is happening. There is some clarity which you also need. I will know because you are not responding. You are all quiet. So and just drop a message in the comment section so that I know what is happening. Right. So let's continue. Let's continue. I will share my screen. Right. So now we have solved for A is equals to half. Now we are going to solve for B and C by letting x equals to negative 2. We are going to let x equal to negative 2. Then solve for A, B, and C. X equals to negative 2. So the approach when you are solving these partial fractions is the same. You are going to equate coefficients. So you must be in a position to know what is it that you are equating. What is it that you are equating there on that coefficient. So now we have solved that A is equal to half. A we now know is half. these are. So now we are going to the next part for equating the constants B and C. Now that we have found that A is R, so which means we still have our problem x squared. So it's still x squared plus 2x, x squared plus 2x minus 1 is equals to A, brackets. But now we have found A. So instead of writing A, we have solved for A. Now let's put the half. Put the half, bracket, 2x squared, if you have expanded, 2x squared plus 3x minus 2. Plus 3x minus 2. This is the first term when we replace A with half. Plus bx minus 2. So plus bx x plus 2 plus cx plus cx bracket 2x minus 1, like that. So this is our term which we are having. So now we are saying let x be negative 2. So if x is negative 2, we want to know what is it that is going to happen if x is negative 2. And remember, A also vanishes. This term vanishes if x is negative 2. This term vanishes if x is negative 2. And also this term vanishes if x is negative 2. So which means this is out when x is negative 2. And also this is out when x is negative 2. So which means it goes out if x is negative 2. So now we are left with, if x is negative 2, which means x squared plus 2x minus 1 is equals to x is negative 2. So this is C multiplied by x, bracket 2x minus 1, bracket. So if x is negative 2, what is the value of C? So now we are replacing everything. Negative 2, so x is equals to negative 2. So this is what we are replacing in this expression. So whenever there is x, we are putting negative 2. Negative 2 squared is 4 plus negative 2, which means plus x is negative 2. So which means plus 2 bracket negative 2, which gives us negative 4. So 2 times negative 2, which means negative 4, minus 1 is equals to, then C times negative 2. So it will be negative 2C multiplied by what? Bracket negative 2 by 2 is negative 4. Negative 4 minus 4, which is negative 5. So that's where we are. So now we want to solve for C. We want to solve for C. What is the value for C? So once we are there, now we can solve for C by saying, what? 4 minus 4 is 0 minus 1, negative 1, is equals to negative times negative, positive 10. So it's equals to minus 10C, minus 10C. So what is the value of C? So here it implies that C, when you divide both sides by negative 10, there by negative 10, and also there by negative 10, which implies that what? C is equals to what? positive 1 over 10. So this is our constant. Positive 1 over 10 is our constant, which we got. And before we got A is half. This is another constant that we got. A is half. So now where we are left is now finding C. 1 over 10. A is half. What about B? How can we solve for B? So we know C, we know A, and we want B. So B, when X is 0, you can't. So for B, we rather put when X is 1. Then we can solve for B. So we equate the coefficients. If you say when X is 1, then we can find what is the value for B when X is 1. When X is 0, B will vanish. So we need things that will make the B not to vanish. For example, if X is half, let's say if X is half, by letting X equals to half, which means C and A will vanish if X is half. So we are going to let X equals to half. So in this case, which we are doing now, let X equals to half. We are going to use elimination. Let X equals to half. So we use let X be equals to a half, which means A will go, and also CX will vanish, which means CX will also vanish if X is half. Okay, so in other words, what is it that we are left with if X is half? If X is half, now we are left with just one expression which says that X squared plus 2X minus 1 is equals to dx bracket X Right, so the recording is ready. I will share, then we can have another example of partial fractions, which we can solve so that we can master these partial fractions. So I will put another example. And this one is now having a higher order denominator, which means it's no longer the same with the one which we're having, which was just a linear. There is another one with a quadratic denominator. So that is the one which we are supposed to do. So let's continue. Then I'll put another one for the quadratic. So I'm going to share my screen as well. So let's have another partial fraction which we are going to share so that we can master the technique and the hints which are required when it comes to partial fractions, whereby you are supposed to equate the coefficients, etc. So I'm sharing my screen. Put another example there, which is from a previous question paper, 22. Again, yes, regression by partial fractions. Regression by partial fractions. So this was the answer for the previous. I was equals to that. And then don't forget always to add plus. And here the trick was here. This is going to, when you use chain rule, you're going to say ln of this multiplied by the derivative of what is inside. So the derivative of what is of that is going to be ln of absolute, absolute of, I forgot the ln inside the bracket. Let me correct that answer. It's supposed to be ln inside the bracket, and I did not put the ln inside the bracket. So let me correct the answer. Let me correct that answer. That is correct. So here there is ln inside the bracket, which I had forgotten. Put it in red color. Ln. Absolute of ln, absolute of that, minus ln, which means here there's supposed to be ln as well. Here there's supposed to be ln. Then here I forgot another ln. So let's put that ln there. Yeah. Ln absolute. Yeah, I think it's correct. There's the ln of absolute, ln of that. Absolute x. So we leave that. Right, so Tendo was saying I was on mute. I think I have rectified that. So let's go to the next one. I think, thank you for that note. I'm checking the messages saying that I'm on mute and then I'm rectifying. Now I think I'm not on mute. Sorry for that. Sorry for that, guys. Apologies. Let's move. Let's move. Let's move. I want you to pass. Let's have another example on partial fractions, which we are going to play, which we are going to work on, and then we see how it goes. So let's go to the next example, which I have designed for partial fractions from a question paper. And the approach is the same. The approach is the same for equating constants, etc. The approach is the same. So once you master one or two, you'll be able to do the rest. Right. So when to put it there, then we see. Right. So this one is saying the integral, in other words, I is equal to the integral of 18 over x plus 3. I is equal to the integral of 18 over x plus 3, bracket x squared plus 9, bracket x squared plus 9, like that. So first you must see that it's 18. So first you must see that, and obviously don't forget the dx. The dx is very important. So first you must see that there is something that we can square at the denominator. So it's already expanded. So you are supposed to split. This is quadratic and this is linear. So this is linear, this is quadratic. So there is an expression of splitting and linear and quadratic into partial fractions. So first you must have that technique of splitting. How do we split that into A, B, and C? So we have already mentioned that that is our I. So now we want to split that fraction into A, B, and C. So we are saying 18 back. All right, all right. Let's continue. Let's continue. Let's continue. Let's continue from where we have left. Sharing the screen. Right. So let's continue from where we left. So now we are saying we want to find the constants A, B, and C. Now we are going to look for those constants A, B, and C. That's what we'll be doing. We're looking for those constants A, B, and C. So for A, B, and C, just do like what we did before. How many times does x plus 3 get inside x plus 3 bracket x plus 3 squared, x squared plus 9. So let's open the worksheet and see it while we are doing. Right. So that's where we are. So we want to equate. Now we want to equate the constants. We want to equate the constant. So what we are saying now that this denominator of ours, this one, goes into this one how many times? Then you can equate. So you'll be saying 18 is equals to, so that 18 is equals to, now we are having constant A bracket x squared plus 9. That is what is left out. Okay. Then you also check this goes into there how many times? Then it's a different store. So now it will be bx to b plus bx plus c is the numerator multiplied by what is left out, which is x plus 3. X plus bracket. So now we want to equate our constants. What is what is what? So what are we going to let in? Let x equals to 3. Which one is going to vanish? B and Z will vanish. If x is what? Equals to 3, which one is going to vanish? X is equals to 3. So if x is equals to -3, let's check. -3, which means B and C vanishes, then you can solve for x -3. Okay. So we let x equals to -3. So this is what we are going to do to eliminate. Let x equals to -3. So once we let x equals to -3, what are we going to get there in our equation? X is equals to -3, which means that 18 will be equals to x is -3, -3 squared, which means it will be a bracket 9 plus 9 bracket plus 0. The 0 because x is -3. -3 plus 3. -3 plus 3, 0. So the 0 is coming from a 0. Because -3 plus 3 is 0. -3 plus 3 will give us 0. 0 times that is 0. So in other words, 18 is equals to 18a. A is equals to 1. So 18 is equals to 18a, which implies that a is equals to 1. A is equals to 1. So once you know your a, now you can solve for b and c. That's what we want to do now. We now know what a is. So a is that. A is that equals to 1. Now we want to solve for b and c. So let's solve for b and c. So this is our a is equals to 1. Found it by eliminating, letting x equals to -3. Then we continue again, eliminating. We look again. If we know that a is 1, okay, a is 1, then if we let x equals to 0, if x is equals to 0, which means we are going to eliminate b, if x is equals to 0, and then we know a, the value of a already, then we can solve. So if x is equals to 0, which means b is gone. So let's go with x equals to 0. We can go with x equals to 0. So we let x equals to 0. So after letting x equals to 0, then we see which one is going to go, and then which one will be left out. So in other words, if x equals to 0, which means that x is equals to 0, which means that on our expression, what are we going to write if x is equals to 0? So which means we know that 18 is equals to a. 18 is equals to a, which is 1, bracket x squared plus 9. That's what we know, bracket. And then b plus bx. Where there is bx, we said x is equals to 0. So it's going to be 0 plus c, which is c. 0 plus c is just c, bracket. X plus 3, we said 0 plus 3, which is 3. So x plus 3 is 0 plus 3, which is 3. But we can put it there and say x plus 3, something like that. So it's x plus 3. Okay, because x is 0, so b vanishes. So bx, if x is 0, bx vanishes, comes 0, because of the situation x is equal to 0. So now we can solve with x equals to 0, a is 1. Now we are going to be left with 18 is equals to 9. 0 plus 9 times 1, 9. X is equals to 0 plus 3c. So now we can solve for what? We can solve for c. We can solve for c. Easy to solve for c now. By saying 9, which is 18 minus 9, is 9, is equals to 3c. Then we solve what is the value of c. So by dividing both sides by 3, divided by 3, then it implies that c is equals to positive. C is equals to positive. So now we have found the value of c, which are having positive 3. So c is positive 3. That is our coefficient. And then from there, we have the value for c. What is b is short. So c, we now know what is the value of c. A, we now know what is the value of a. Now, what is left is for us to, we now know the value of a, we now know the value of c. Now we want to know the value of b. So how are we going to solve for b? That is the situation. Right. So what are we going to get to? But we know a is equals to 1, c is equals to 3. Then we can play around with the values and then equate to the constant. So since we know x, we know a, we know b, and we know c. B is what we are supposed to look for. A and c are now known. So we let any value for x, and the c in the b can come out. So let's do it in writing. So what is it that we are talking about? We are saying that 18, our constant, the numerator, is equals to a. A, we now know what is a. 1 bracket x squared plus 9. X squared plus 9. That is our a plus bracket bx plus c. Right. So if x is equals to 1, what is the value of? I will share my screen and then here from there, sharing the screen. Let's start. X is equals to 1, what is the value of b? Right. I will share my screen. X is equals to 1, what is the value of b? Right. Screen is opening. Let's just be patient. See how everything goes. If x is equals to a is equals to what? And b, c is equals to 3. We found the value of a equals to 1. So we want to look for the value of b. To look for the value. Right. So we can see that even in this, we can equate the coefficients of b. We are able also to equate the coefficient. However, let's continue. If we let x equals to 1, what are we going to get? So we are going to say 18 is equals to 1, which is 1 squared plus 9, which is 10. So 1 squared, 1 plus 9, 10 times 1 is 10, plus b times x, which is just b, plus 3 multiplied by x plus 1, which is multiplied by 4, multiplied by x plus 1, which is 4. So we want to know what is the value of that b. So then we continue. We are going to say 18 minus 10, 18 minus 10, 18 minus 10, 10 is equals to 4b plus 12. Equals to 4b plus 12. We expand the bracket. Now 18 minus 10 minus 12 is equals to 4b. What is 18 minus 10? That is 8 minus 12. What is the answer of 8 minus 12? Which is minus 4. So in other words, minus 4 is equals to 4b. From there, we solve for b. So now, what is the value of b? By dividing both sides by 4. All right. Right, so we now know the values of A, B, and C. Now it's a matter of us finding what is the integral in terms of I is equals to what. So that's where we are going to share now on the screen. Apologies, the network you can see on my screen is not that excellent, but I will check why is the system keep on chasing me to rectify it in future sessions. So let's continue with our partial fractions today. Do the partial fractions so that tomorrow maybe we can touch on trigonometry substitution. So let's continue. So what we are saying that now we want to find the answer. We have split into partial fractions A, B, and C. It's a matter of now solving. It's a matter of solving now. While the screen is opening, let's see how it goes. Any questions so far? You are not responding, no text. The communication breakdown. If we are responding now, but we are there, guys. Right, wait. Everything. Okay, so we have equated, we have found our constants, we found the constants. Now it's a matter of us solving for that question. So let's solve the question now. So what is our I equals to? So that I which we wrote there in the beginning, we don't have to copy it now, equals to. We said that I is equals to the integral of A. So it's the integral of A as integral of A over x plus 3 plus dx over x squared plus 9 plus c over x squared plus 9. And then don't forget everything. I'm applying it by dx. Everything is multiplied in the bracket by dx over x squared plus 9. So we are there. We now know A, B, and C. So what we are going to do, a matter of now replacing our A goes where it's supposed to be, B goes where it's supposed to be. A is 1, B we found -1, and C we found it B 3. So let's continue from there. So just for recap, our A was equals to 1, B was equals to -1, and our C was equals to 3. That's for recap, so that we know we are on the same page. So that is what we have in now. So from there, so this is what we are having. So from there, now we want to know what is the answer. We are given that situation. Where is that? So already for the first one, you know the answer. Lim absolute of x plus 3. So I is equals to lim absolute of x plus 3. Right, we are done with that part. Then the second part, -1. So for -1, which means we are equating it to term, but we are going to put the negative outside. In other words, it's going to be negative where we are going to be having x squared plus 9. Remember, when you differentiate term, what is it that we are going to get? So it will be the ln of x squared plus 1. But for this case, remember the 2. When you differentiate the denominator, we are going to get a 2x. But in our case, we don't want the 2x. We want only bx, so it will be plus. Remember, when you differentiate 1 over x squared, d dx of 1 over differentiate d dx of ln of absolute x squared plus 9. If we differentiate this, we are going to get 1 over x squared plus 9 multiplied by 2x on the numerator, multiplied by 2x. So the d dx of this expression is equal to that. But us, we don't want the 2x. We only want the x. That's why we are putting a half. Because we don't want the x. That's why we are putting a half. So the denominator half will cancel the x, which is the denominator. That's what is going to happen. So it will be half ln of x squared plus 9. That's what we are going to get. So it will be half bracket, it will be half ln of absolute x squared plus 9. Absolute. Fine. So plus or minus. So let's see, what are we going to get? X squared plus 9. So half of ln x squared plus 9. Then this side, we want to know what is it that we are going to get. It's equivalent to what? We can equate it to tan. When you equate it to tan, for example, 1 over a tan x minus 1. Remember the integral of tan d dx integral for tan. So we are still continuing with the equation. This is out. So don't confuse it with part of our answer. It was just clarification of where the half is coming from. This is not part of the answers. It was just showing us where the 2, this one, is coming from. Okay. So from there, we want to integrate this part. Now we want to integrate the last part. The second one we are done, which is ln, half ln, absolute that. Now we want to integrate this one. So we want to know what is the integral of that. But we can see that this thing is related to tan. The tan is the one that is x squared plus 9, which is a squared plus x squared. So let's go and see what we are going to do. For integral of tan, just as working, we know that the integral of 1 over x squared plus a squared, the integral of that dx, it's going to be equals to 1 over a, which is that arctan of x over a, arctan of x over a. So in that case, we want to equate it to that situation which we are having now. Like, how are we going to equate this C, whereby it's 3? So where there is C, we are going to put it. So instead of writing 1, we are going to put a 3. So this A in our case are given integral. We are having 3 over x squared plus 9, which is 3 squared. Right. So which means that 3 which we are talking about, let me show you how the 3 disappeared, which is on the numerator. So I'm going to share the screen and I show you how the 3 disappeared. Let's share the screen and you see how the 3 disappeared. Let's go to see how the 3 disappeared. And see how the 3 disappeared. Okay, continue. I will show you how the 3 disappeared. So for tan, it's a bit tricky. It's 1 over a arctan inverse of x over a tan. So you might be careful about that. For tan. Right. So in this case, how did these 3 disappear? These 3. The 3, we are saying, how did that 3 disappear? So that 3 you can put outside the integral, whereby it can be outside the integral. Although it's inside, but the 1, this situation, it's like this, like a 3 multiplied by 1. Okay. There's a 1 there. There's 3 multiplied by 1. This is our C. Remember, this is the C. So this is the C. So 3 multiplied by that will give us this. And don't forget that multiplied by the 3, which is the C, which is this one. So that's why the answer, these values, they are going to cancel, and then we'll be left with arctan x over 3. So our answer there, so it will be equals to this answer. Then say again, C, B, and the C, so B was negative x squared, x over x squared plus 9. It was a negative, that is a negative B. Then also the sign, it has to be negative sign. It has to be a negative sign. What do you mean by that? Negative sign. Why is it going to be a negative sign? Because here our B is negative 1. So also here the sign is supposed to be negative. The sign is supposed to be negative. Sign is supposed to be negative. Sign is supposed to be negative. Negative. Coming from B is negative 1. So the sign is negative. Right? Then we are going to add plus. Next answer, which we are going to add to that one, plus C. The answer which we are going to add, since that one is going to cancel, then it's going to be plus arctan inverse of x over 3. X over 3. Then don't forget to add plus C. So this is our answer. Everything is our answer. Okay. So everything was to that. So this one down there was just a working, showing you how the answer for tan was obtained. So for tonight, we can stop here. If there are questions, you can drop them via inbox. Then I will respond. Where you do not understand, you can just screenshot. I will share also the video link. I will also share the video link so that you can also look at it. Where there is a mistake, I can explain. And where there are mistakes, we can rectify together. But the answers are verified. I have verified them before I present it. So this is what we've done to the partial fractions. Then this one was the answer plus C. The negative is the EX negative. So the time you must know the integrals. Getting elimination, done that. Getting x equals to negative 3, elimination. Also, when we started the integration by parts, we started here by saying we're going to split it into partial fractions, something over denominator of x, something over x. So this was over linear. There are some whereby they are no longer linear, they are quadratic like the second one, but the approach is just the same. And end here for today. If there are some questions or problems, if you need clarity, just drop them in the inbox. Tomorrow we'll meet again. We'll continue from where we left. Yeah. See how it goes tomorrow. See how it goes tomorrow.